In the last several years, we've seen widespread adoption of artificial intelligence, or AI, across industries and sectors. You likely interact with AI in your daily life, probably in the form of machine learning algorithms. These algorithms can be found in things like recommendations for shows or movies you might like, to product suggestions from major retailers like Amazon, to robots, to self-driving cars. Given the ubiquity in the use of machine learning and artificial intelligence, it's easy to see why it's important for these algorithms to be tested before they are implemented. Considering all the safety implications of a driverless car is a great example of how critical it is for all algorithms to be thoroughly tested and tuned before they are used in a consumer setting. When we consider a military context, it's even more important for any ML or AI algorithms to be tested before being deployed. The military, by definition, works in geopolitically and strategically sensitive areas and circumstances, meaning our equipment needs to reliably work as intended, or the consequences can be negative and far-reaching. Given the importance of testing algorithms before they are implemented in a military setting, our team has created an applied framework and a Python package to assist machine learning teams in crafting safe and efficient machine learning. It's called the Army Artificial Intelligence Testing Framework, or A2IT for short, and is a set of instructions, considerations, and suggestions for teams to follow once they've developed a model or system that uses machine learning. Given the organizational mission of the Artificial Intelligence Integration Center, we designed this framework to be used by programmers or data scientists. The AI2T diagram begins with the intended audience of the machine learning ops team that conducts ML model development. The first subsection of A2IT is internal model testing, or IMT. In this section, after an initial consultation with system teams or project stakeholders, ML ops teams will follow standard practices for basic model development and determine if their model adds value and helps solve a problem. Teams implement the process of internal model testing using the machine learning test and evaluation package, which can be easily imported to any Python interface. After IMT, the team will then decide if their current model performance exceeds the minimum baseline. If performance is substandard, they will repeat IMT until the model performance improves or until the model is determined to be non-viable. When and if the model performance exceeds the baseline, the MLOps team will again consult with systems representatives or project stakeholders who will be utilizing the model in a larger system. The next section of A2IT is System-Dependent Model Testing, or SDMT. This section is dedicated to ensuring teams have the information they need to consider the priorities, trade-offs, and weaknesses of their model in the context of a system. Given the breadth of considerations within each category of machine learning, this is not an exhaustive list, but rather the major priorities we have identified from research so far. It includes 3 categories: functionality, robustness, and cost. We anticipate this section of the framework expanding over time, and therefore have depicted an unlabeled category signifying future additions. Once teams have determined which properties of SDMT to prioritize and evaluate, they will then stop again to assess the overall performance so far of the model and system. This assessment will happen again in close coordination with the system teams or stakeholders who have the ultimate say on if the model performance is acceptable. SDMT is meant to be an iterative process, so there will likely be many rounds of reprioritizing and reevaluating metrics within SDMT categories. If the model still does not perform well, teams may need to return to IMT with a new or significantly altered model. Once the model team and systems team agree the model is effective, they can then return the final model and automatically generate a report that details important model characteristics and the results of the MLTE evaluation. As demonstrated by this report prototype, the idea is to have a human-readable output that can be customized to each project. This is a useful format that communicates confirmation that the ML-enabled system meets all requirements and performs as intended under a variety of conditions. MLTE provides a method to streamline the process necessary to involve systems representatives and stakeholders in executing an effective machine learning system. While our A2IT framework and current MLTE implementation have limitations, we will continue to improve both with time and iterations. Test and evaluation is a critical step in ensuring safe and efficient ML systems, and this is a strong first step for the AI2C. Our project helps ensure consistency of evaluation across disciplines of machine learning, enabling both ML teams and stakeholders to fully understand their system's purpose and limitations.